In this video, I am going to discuss sample questions about quadrilaterals that can be very useful in answering your summative test. So, come on, let us enjoy learning mathematics. First question. How do you call a quadrilateral with two pairs of parallel sides? So we are just going to use the clues that are present. We have two pairs of parallel sides. Now, if you are reading at the same time understanding your module, then this question is very easy. Quadrilateral with two pairs of parallel sides is called a parallelogram. That's it. Next question. How do you call a parallelogram with four right angles and four congruent sides? So the clues are the following. We have four right angles and four congruent sides. Recall that when you have a parallelogram, we have three special types of parallelogram. First is the rectangle. By definition, a rectangle has four right angles. And the next is a rhombus. A rhombus has four congruent sides. But in the question, we are looking for four right angles and four congruent sides. And that is actually the square. A combination of the properties of a rectangle, four right angles and four congruent sides. So that is a square. Next question. Rectangle has blank right angles. As I said earlier, rectangle has four right angles. Next. The diagonals of a rectangle are blank. So this is one of the theorem under special types of parallelogram. And always remember these important theorems. The diagonals of a rectangle are congruent. But for rhombus, it's perpendicular, and then again, for square, both congruent and perpendicular. The blank of a triangle is a segment joining the midpoints of two sides of a triangle. So let me first illustrate the statement. You have a triangle, and then you are going to have a segment that will connect the midpoints of the two sides of a triangle. So for example, these are the two sides that I choose. And then, assuming this is the midpoint, then I'm going to connect. How do we call this segment? So is it the altitude, the midpoint, the midline, or the hypotenuse? Actually, the midpoint is very, the most far out choice, because in a triangle, we don't have a midpoint. We have midpoint on a line or in a segment. Therefore, the answer is the midline. It's the midline. Altitude is a segment from the vertex perpendicular to the opposite side or to the base. Hypotenuse are only present in a right triangle. So, not all triangles have hypotenuse. Next. The area of a kite is half the product of the length of its blank. Again, this is one of the theorem. When you say kite, to find the area of the kite, just multiply the diagonals and divide it by 2. So therefore, for this question, the answer is diagonals. We need to multiply the diagonals and then divide it by 2 to find the area of a kite. Next. Quadrilateral BESET is a parallelogram. If the measure of angle B equals x plus 30 degrees and the measure of angle E is equal to 2x plus 10, what is the value of x? So basically, when you have problems like this, best thing to do is to draw the parallelogram and label it accordingly. So for example, this is our parallelogram, BSET. And then you try to ask yourselves the given, which are the measure of angle B and the measure of angle E, if what's the relationship between the two angles, so angle B and angle E. And it's very obvious that these two angles are opposite angles. Therefore, we can generalize that angle B is congruent to angle E. And since they are congruent, it means that their measures are equal. So we can say that x plus 30 is equal to 2x plus 10. And then the rest is history. We need to solve for the variable. Now, again, it is my practice that when you are solving for the variables, you look at which side has a greater numerical coefficient. For example, for x and 2x, 2x is greater than x. So, I like to transpose x to the right side and then the 10 to the left side. So we will have 2x from positive x to minus x. So we have 2x minus x, and then from positive 10 to minus 10. So that's 30 minus 10. 30 minus 10 is equal to 20. 2x minus x is equal to x. And then that is x equals 20. And then if we go back to the problem, what is asked is the value of x. Therefore, we have the value of x. X equals 20. That's it. Next, opposite angles of an isosceles trapezoid are blank. Now, if you can recall, opposite angles in a parallelogram are congruent. But that is for parallelogram. For an isosceles trapezoid, it's different. Because for isosceles trapezoid, what are congruent are the base angles. The angles on the top, the two base angles, and the base angles at the bottom. Therefore, opposite angles of an isosceles trapezoid are supplementary. They are not congruent. Next, quadrilateral POST is an isosceles trapezoid with OS parallel to PT. This is the symbol for parallelism, and it's very important to know what sides are parallel when we draw the isosceles trapezoid, because we only have one pair of parallel sides. If we do it wrongly, then we cannot have the correct answer. If the measure of angle P equals 7x plus 15, the measure of angle S equals 3x minus 35, what is the measure of angle P? Again, first thing we are going to do, if the illustration is not given, we need to illustrate. For example, this one. Now, in your illustration, make sure you are following the given. First, OS is parallel to PT. When you have this one, it means that OS and PT should be the bases, the upper base and the lower base. Because the other pair of sides are not parallel. The congruent sides of the isosceles trapezoid, they are not parallel. And then, it is also important that you know how to put the vertex P, O, S, and T. Next, measure of angle P is 7x plus 15 and measure of angle S is 3x minus 35. What is the measure of angle P? Now we are going to analyze what's the relationship between the given angles, angle P and angle S. Angle P and angle S. So it's very obvious that they are opposite angles. But since we are dealing with an isosceles trapezoid, then angle P and angle S are supplementary. That's why we can have measure of angle P plus measure of angle S equals 180 degrees. And after having this equation coming from the theorem, we can now proceed in solving or substituting and then find the value of x. Measure of angle P is 7x plus 15. Measure of angle S is 3x minus 35. And that is equal to 180 degrees. So what we can do next is to combine like terms. 7x and 3x. So we have 7x plus 3x plus 15 minus 35 equals 180. And then combine. 7x plus 3x is equal to 10x. 15 minus 35 is equal to negative 20. And that is equal to 180. Next, since we want to find the value of x, we need to transpose the minus 20 to the other side. So we can have 10x equals 180 plus 20 from negative 20 to positive 20. And then simplify further, 10x equals 200 from 180 plus 20, and then divide both sides by 10. That's why you will have x is equal to 20. But what is asked in the problem is the measure of angle P. So we will not stop at this point. So we continue. Measure of angle P is given to be 7x plus 15, and then we substitute the value of x to x. So you will have 7 times 20 plus 15. And 7 times 20 equals 140 plus 15, that is equal to 155. Therefore, the measure of angle P is equal to 155 degrees. Okay, that's it. Since we are dealing with quadrilaterals, another problem we have is a rhombus. It's not star, it's read as STAR, is a rhombus with diagonal RT. If the measure of angle STR equals 3x minus 3 and measure of angle ART equals x plus 27, what's the measure of angle RAT? So in grade 9 learners material, this is one of the complicated problem because you will have a long process in solving this one. Again, we need to illustrate rhombus STAR, and then one of the characteristics of the rhombus is all the sides are congruent. And then the given measure of angle STR. Measure of angle STR. Angle STR is located, you follow STR. Where is the angle form? The angle form is here. So that is angle STR, and the measure is 3x minus 3. Another angle given is angle ART. ART. So where is the angle form? Okay, it's here, angle ART. Now, since a rhombus is a parallelogram, it means that these lines, these sides or these lines are parallel. So we can apply the theorems about parallel lines cut by a transversal. And that is your lesson during your grade 7. Alternate interior angles are congruent. So these are alternate interior angles. That's why they are congruent, because they are alternate interior. Now we are going to start our solution in this part because these are the given. So we can equate the angle STR is congruent to angle ART. That's why the measures, their measures are equal. 3x minus 3 is equal to x plus 27. And then we solve for x. 3x is greater than x, so I will transpose to the left side. 3x minus x equals 27 from minus 3 to positive 3. 3x minus x equals 2x. And 27 plus 3 is equal to 30. Divide both sides by 2, we have x equals 15. So that is just the value of x. The question is, what is the measure of angle RAT? Angle RAT is angle A, this angle. So meaning x equals 15 is not yet our final answer. We need to substitute this to any of these two. Anyway, they are equal. So I choose angle ART, which is x plus 27. So when I substitute, I will have 15 plus 27. 15 is from x. 15 plus 27, that is equal to 42. So the measure of angle ART is equal to 42 degrees, and that is this angle. It's 42 degrees. So physically, this angle also measures 42 degrees because they are congruent. But if you can recall, in one of the theorems under rhombus, diagonals bisect opposite angles, meaning when you have a diagonal for the rhombus, it bisects angle T and angle R, meaning what's the measure of this angle is also the measure of this angle because it is a bisector. So this is also 42 as well as the other side. And if you are going to check, alternate interior still are congruent, 42 degrees and 42 degrees. So basically, the measure of this angle, if we add, measure of angle R is 84. So why I need to find the measure of angle R? Because we are looking for angle A, or the measure of angle R 80, the measure of angle A. So I can have it this way. Angle R and angle A are consecutive angles. And since rhombus is a parallelogram, the property that says consecutive angles are supplementary will also apply to rhombus. So we can have measure of angle R80, or the measure of angle A, it's 180 minus 84. So that is equal to 96 degrees. Now if you are going to add 96 and 84, you will have 180 degrees, making angle R and angle R80 supplementary. And that's the answer. Next, under quadrilaterals, or under the MELCs in grade 9 mathematics, several competencies require you to prove or to write a proof. So I just included one problem: rhombus Fi in E with diagonal Fn. So the illustration, rhombus Fi in E, diagonal is Fn. We are going to prove that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. And then it's not difficult because we are already given with the table. And then I'm doing a proof, especially you are dealing with parallelograms. One of the technique is to divide the parallelogram into two triangles, and then you prove that the two triangles are congruent, and then you are going to use the CPCTC. Congruent parts, corresponding parts of congruent triangles are congruent. Now let's go to the proof. For the two-column proof, it is composed of the statements and the reasons. And again, this is not hard because you are already given with the statements. You are only to supply reasons. Now, quadrilateral FINE is a rhombus, and that is very obvious because when you look at the given, that is the given. That's why your reason is given. Next, FE is congruent to NI. EN is congruent to IF. For this, you can have a lot of reasons. You can have definition of a rhombus, or the property of a parallelogram which says opposite sides are congruent. You can also have definition of a rhombus because for rhombus, all the sides are congruent. And since it's given, we just follow definition of a rhombus because they are opposite sides. Now, why are we doing this one? Because we are dividing our rhombus into triangle. This one is the first triangle, the second triangle is this. So if you are going to look at the next part, we have Fn is congruent to Fn, this segment. Because this segment is common to the two triangles, and it's very easy to prove because we can apply reflexive property or the reflexivity. This segment is equal to itself. That's it. And then if we are going to illustrate this one and this part, FE is congruent to NI. That's it. FE and NI. Notice that what is corresponding are this vertex and this vertex. So FE and NI. So F and N are corresponding with each other, same as E and I, vertex E and I. Next one is EN is congruent to IF. Observe that if we start with E, on the other segment we start with I because they are opposite angles, so this should be the corresponding angles. And then the last given, or the last part given in the proof is this. Fn is congruent to Fn by reflexivity. So basically, if you are with me, you can see two triangles. And these two triangles are congruent. Triangle FEN, this triangle, and triangle NIF, they are congruent because of the SSS congruence postulate. The side, side, side. I think you can still remember that because that was your lesson during your grade 8 times. And then after that, since the two triangles are already proven to be congruent, we can use the CPC-TC to say that the corresponding parts are congruent. So angle 1 and angle 2. So it's very important that we know the correct correspondence. Angle 3 is also congruent to angle 4, and that is because of CPC-TC. And that's all. Thank you for watching.